Hello everyone, my name is Aditya and today I'm going to explain you different type of processor used in model computing and artificial intelligence system. We will cover working, advantages, limitation, and finally its application. The modern computing system use different processor for different tasks. Earlier computers mainly depended on CPU for all operations. But with the growth of artificial intelligence, machine learning, specialized processor become important. GPU, TPU, LPU, NPU was developed to improve speed, efficiency, and AI performance. Each processor has its own architecture and the area of application. The main goal of this presentation is to understand the difference between different processors. So let's first understand one by one. First is CPU, Central Processing Unit. It is known as the brain of the computer because it controls and manages all operations. CPU performs calculation, logic operation, and system control. It is optimized for sequential processing and low latency tasks. It also handles operating system, applications, and user commands. The CPU is best for general purpose computing. If we talk about this working, was the instruction fetch, then decode, then execute, then catch access, and then output. Its advantages are it can handle almost every task. It has stored single thread performance and controls overall system limitation operations. Its limitations are it is slow for large AI workload. It has lower parallel processing capability. Example of CPU are Intel Core processor and AMD Ryzen. The next is GPU. GPU stands for Graphic Processing Unit. GPU is specially designed for graphic rendering and parallel computing. It contains thousands of small code that work simultaneously. A GPU is best for gaming, animation, and video editing, and AI training. It performs matrix calculation much faster than C. That is why GPU is widely used deep learning application. Now it's working flow. So first the input data, then the thread distribution, then CUDA code execution, then shared memory, and then finally the output. Massive parallelism, fast AI training and interference, excellent graphic performance are its advantages, and high power consumption, expensive hardware, and not efficient for simple tasks are its limitations. We talk about its applications. NVIDIA GeForce and AMD Radeon graphic cards are its applications. The next is TPU, that is Tensor Processing Unit. It is specialized AI accelerator developed by Google. It is mainly designed for tensor and matrix operation. It is used systolic array architecture for high-speed AI consumption, AI computation. TPU is optimized for machine learning models and training and inference. It is mostly used in cloud data centers. It takes first input data, then wait buffer, then systolic array, then SRAM, then HBM memory, and then the output. Its advantages are faster AI computation, better performance per watt, efficient neural network processing, and its limitations are less flexible than GPU, mostly cloud-based, limited support outside AI work. We talk about its application. It is image recognition, speech processing, large AI models. The next processor is NPU. NPU stands for Neural Processing Unit. It is designed specially for neural network operation. NPU is commonly used in smartphone and edge AI devices. AI provides low power AI processing directly on devices. It also supports real-time AI feature with internet dependency. This improves efficiency of mobile AI applications. With workflows goes like this. Uh, User input, then tensor buffer, then neural compute engine, then activation engine, then finally the output one. Energy efficiency, fast on-device AI processing, low latency performance are its advantages, but it also had limitations such as mainly used for inference, limited memory and flexible, less powerful than GPU for large AI models. Face recognition, voice assistant, and smart cameras are the examples. Then the next term is LPU. LPU stands for Language Processing Unit. It is optimized for language-based AI and large language models. LPU is designed for fast tokens generation and real-time responses. It focuses on deterministic and low latency AI execution. It is mainly used in AI chatbots and conversational system. LPU improves the speed of natural language processing. Its working flow is like that: the input tokens and then functional slices and then on-chip SRAM, then token processing and then the output tokens. To talk about its advantages and limitation: very fast inference speed, low response delay, efficient execution for language models, and but specialized mainly for language AI, limited memory per chip, requires advanced infrastructure. Its applications are AI chatbots, translation system, real-time AI consumption. Now let's compare them with each other. This comparison table shows the difference between all the processors that we discussed earlier. The CPU is used for general computing and work with sequential processing. But CPU is used for best for gaming and AI because it supports massive parallel processing. TPU is specially optimized for machine learning and tensor operation. NPU is mainly used for mobile AI with low power consumption. LPU is designed for chatbot, neural language, and processing using tokens processing. So thank you for your time. I would be grateful for your valuable